My dear students, this previous year question in which a pendulum is dropped from here where u is equal to 0, and here we have to find out the velocity. Okay, what is the speed at the bottommost point that is here? For that you can write v square minus u square is equal to 2gh plus 2gh. As initial velocity is 0, this part goes, and you know v is equal to square root of 2gh. You have to find out this height. So how are you going to find out that height here now? This height. To find out that height, h is equal to, this is the total length and this is L cos theta, only that much part of the length. The component of this, it is taken as L minus L cos theta. So h is equal, if you common out L, you will be getting 1 minus cos theta. That's it. That h, if you substitute here, get the final velocity. That is v is equal to square root of 2gh. H means L into 1 minus cos theta. So this can be taken as a shortcut formula, and in some other questions he may ask, if a pendulum is dropped from 60 degrees, what happens? That means you have to consider theta is equal to 60 degrees, and you can find out h is equal to square root of 2gl 1 minus cos 60. So if it is cos 60, then you will be getting how much? You will be getting just root gl as height. Okay, so if you take it as 120 degrees, if it is dropped from 120 degrees, how much you are going to get? Okay, you just find out and tell me the answer in the comment section. Thank you very much. Have a my dear, so kinetic energy and momentum relation. Based on this concept, 5 times the question was asked. Let us discuss the question one by one. So here, if you observe, let us discuss what is the relation between kinetic energy and momentum first of all, before going to the 5 questions to be solved now. So the concept here is, you all know, kinetic energy is nothing but half m v square. Okay, so in this, kinetic energy is equal to half m v square, multiply numerator and denominator with m, then you will be getting k is equal to m square v square by 2m. And you know momentum is nothing but mass into velocity. You also know that here you will write kinetic energy is equal to p square by 2m, because p is equal to m into v. So based on this relation, we got the relation between kinetic energy and momentum as k is equal to p square by 2m. So all the 4 questions are related to only one concept, that is k is equal to p square by 2m, which is such a simple concept here. Let me discuss one by one. So here, from this concept it is understood that k is p square by 2m, momentum p square is directly proportional to m here. Okay, that means p is directly proportional to root m. So we can write here p1 by p2 is equal to root of m1 by m2. So here, what is m1 here? It is taken as m by 4m. So LX cancel, answer is 1:2. So C option is going to be a correct answer. Similarly, you can go for the next one. Here also we can write p1 by p2 is equal to root of m1 by m2. So here m1 is taken as 4 by 1, that is 2:1. So 2 by 1. So C option is going to be correct answer. Similarly, we can go for the next question also. Here also p1 by p2 is equal to root of m1 by m2, that is 1 by 9. It's taken as 1:3. So C option is going to be a correct answer. Similarly, here also we can write p1 by p2, answer is 1:2. So C option is going to be a correct answer. So if you want to find a relation between mass and kinetic energy, they are inversely relation. So here, if you observe, mass and kinetic energy are inversely related. We can write this as m1 by m2 is equal to k2 by k1. So what is k2 by k1? My dear students, this video is dedicated to medical students who are unaware of integration and differentiation in depth. So an engine in a car or a lorry is making the vehicle to move forward with certain velocity, and here we need to find out the relation between velocity and time. It is derived in the books by using the integration and differentiation method, and he got that the velocity is directly proportional to t power of 1 by 2. Similarly, in the second derivation also, he is finding the relation between displacement traveled by the vehicle and time. Here also he has used very lengthy methods of differentiation and integration. Can we derive this without integration and differentiation and find the relation between velocity of an engine and time, and displacement of an engine and time? Yes, you can do it. Always a beautiful method. Let us discuss about that. So for that, you need to do one simple thing, that work or energy, you can take work is equal to half mv square, which can also be written as power into time. Because power is equal to work by time, work means power into time. So from this it is understood that velocity square is directly proportional to time. So therefore velocity can be taken as directly proportional to t power of 1 by 2. So within as 2 or 3 steps we got the relation between velocity and time so easily. Next we need to find out the relation between displacement and time. So you can see the lengthy methods given in the books to find out the relation between velocity and time. But is there any simple method? Yes, there is a simple method. The simple method is, you all know work done is equal to half mv square. Okay, and you know power is nothing but work by time. So can we write this half mv square by t? Yes, we can write. And it is said that power is constant. In the problem it is said that constant power is there. So we can take this power as constant. And you also know velocity is nothing but displacement by time. So if you substitute the value of velocity in the above equation, then directly you'll get in the third step the relation. So simple it is. So half m by t, v can be taken as s by t means s square by t square, that's it, which is equal to k. So therefore we can write half m s square, this one more t is there here, so we can take this as s square by t cube is equal to k. So therefore s square is directly proportional to t cube, so we can be written as s is directly proportional to t power of 3 by 2. Okay, so 3 power of t by 2. So directly we got the relation between displacement and time without integration and differentiation also. Hope you enjoyed this relation finding the methods. Thank you. My dear students, here we have to find out the work done in pulling the chain on the table completely. So for that, what we need to do here is, you are going to do certain work to pull the chain completely, which was a little amount of chain, that is 1 by nth of the part of the chain is hanging downwards. So what is the formula to be applied here? So you all know that you can consider W is equal to mass of the hanging chain and G into length of the height of the hanging chain. That's it. mgh. So height of the hanging chain you have to consider. So what is said to be the mass of the hanging chain here? So for that, mass of the hanging chain is nothing but 1 by nth part. So m by nth part of the chain is hanging. Now to find out the height of the hang, you all know that out of L by n you have to consider only half part of the hanging chain. Because it is a uniformly distributed body, you have to consider the center of mass of the hanging part. So center of mass only will be only half of the part. So you have to write half of L by n. So therefore height of the hanging chain is L by 2n, whereas mass of the hanging chain is m by n. So directly you can substitute here m by n into G divided by L by 2n. So your formula is ready, that is mgl by 2n square. You need to find out what is the value of n here. So you all know that n is nothing but, it is going to be how much? N value is nothing but 200 out of 200 centimeters, because 2 meters means you have to convert it to centimeters, or else you can take 200 divided by 60, or you can also take 2 divided by 0.6, which can be converted into here. So finally we are getting how much? You will be getting 10 by 3 as n value. So directly substitute the remaining things here, you will get the answer directly in this formula. So W is equal to mass of the hanging chain is going to be how much? It is going to be 4, G is taken as 10, L is nothing but 2 meters, divided by 2, and n square is nothing but 10 by 3 whole square. Okay, so if you solve, you're getting directly 3.6 joules as your answer. Hope you have enjoyed this micro concept. Thank you very much. Have a nice